Good evening, everybody. Can you guys hear me? And you guys can see my screen. So we are going to continue our class where we stopped the last time. But before we do all that, I will have to walk us through some stuff and explain couples of things to us about authentication and authorization, because that is what we are going to be implementing today. And the API we designed the last time, we designed. Hello. um I know about that, because I don't know, there's a mosque going on and a church program going on. I don't know, it's just something I can't deal with. We design. Hello. I know about it, because I don't know, there's a mosque going on and a church program going on. I don't know, it's just something I can't deal with. All right, good evening, everyone. So this is where we stopped the last time. We were able to create an API to an API to create an employee, to fetch an employee as well, and we're able to connect it to the database. So let me show us the database. So we're going to test the API one more time to be sure everything is still working fine before we implement some other things to it. So the API to get employee is still working, coming from database. So an API to create the employee. So we have the Express library we install and the MySQL library we install. We instantiate the Express server. We pass the JSON, Express JSON, to pass all the data passed to the JSON from the request to a JSON, to convert it to JSON. Also, we set up the ports we want the server to run on. We create a test middleware to always log dates logger, and a landing API request to show us when the API starts. When you go to HTTP and run on port 3000, this is what you get. And also we instantiate database connection, then an API to delete an employee based on the ID passed to it. And as well, we try to instantiate a database connection, then write the query to delete the data, then return the success message. And also API to get all the employee from database. We connect to database one more time, write the query, execute the query, and return the data. The same thing for creating the employee. So we make a database connection where over here we extract data from the request body. Then we write query to insert the data into database, execute the query, and return the success message. Then app.listening accepts the port we want to run the server and the callback to execute when the server is running, when the server starts. So, all right, what we are going to be doing today, we are going to introduce um, a, a method called authentication and authorization, whereby we are going to allow the employee to be able to log in with username and password and protect their data. You should be able to log in to retrieve s- most of this data, to get your data. So those are the things we are going to implement today. And to do all that, we are going to update the database to accommodate user email and password. And we are going to implement an encryption to encrypt the password. Those are the things we talked about in our previous class, encryption. So we are going to work on it today. We are going to practice it today. All right. So this is the slide we talked about, we used in the last class, and today we are going to check some of the things we are going to work on and walk us through it. So I will try and explain most of these things in the pace of 30 minutes so we can get back right to write the code and implement it. So we're going to talk about the authentication and authorization, that is user authentication methods, authorization, access control, and security best practice. These are the things we need to have in mind when we are building a system. And when you're working on the back end, the system security is the most important thing you need to put in mind when you are designing. So these are the things you need to put into consideration. And for you to be able to put it in consideration, you need to actually understand how it works. So this is what we are going to cover. So what is authentication and authorization? Now, authentication basically means access. Authorization means access to data. That is, do you have access to get this data? While authentication means before you can have access to it, we need to verify who you are. We authenticate you, we verify you, data you pass. Do you actually have access to the data? When you insert a key into a door, you need to perform a process of unlocking the door. When you insert the key lock will verify the key you insert into the key lock if it actually match the key lock. So that process is verifying the key. If the key can open the lock, that's authentication. Authorization is when you enter the door, what are the actions you can perform when you enter the door. That's the authorization. So it's basically granting access to resources based on the user permission. So authentication is the process of verifying who someone is, which is what I just explained. Then methods of verifying users. The common one is username and password or email and password, whereby if you want to access any portal, any system, what is required is for you to put in your email, your password, or username or password, or phone number or password, one-way authentication. So that process, if the credentials you insert into the data into the server is wrong, you will not be able to get access to the portal or anything you want to try and access. So now another method to authenticate is multiple factor authentication. I believe every one of us might one way or the other have access to this type of have experience with this thing called multiple factor authentication. So it's a process that requires users to provide two or more verification factors to gain access to a resource. So there is a particular word that is very popular called 2FA, two factor authentication, whereby the moment you input your username and password and the access is correct, the information is correct, yet you will still have to wait, probably receive an OTP to verify that it's actually you, the actual person. That is, the moment you pass the first check, you also need to pass the second check. Probably you input your email and password. That's the first check. It will trigger an OTP into your email. You now input the OTP into the portal, into the authentication. That's 2FA. All the level of check that you must pass through, everything must be right before you can gain access to the portal. So that's what multiple factor authentication means. So now we now have what I explained now. We have password authentication, which is the popular one, the username and password combination, then the password complexity. This is one of the rules. When you are registering on a platform, they will inform you to use multiple layers of password, multiple combination, probably alphanumeric with special characters. That is the best password combination you can ever use. You don't just use a common or simple password like password 123. All these things are very easy to get. You have to use alphanumeric with a password and generate multiple password. Don't just use one single password across all platforms. So that's one of security thing you need to keep in mind whenever you are accessing any portal. Then multiple factor authentication, like I explained just now, you need to combine multiple authentication before you can get access to something, probably using the password and combine with the OTP, which I explained, or a biometric system. We all have smartphone that is registered, that has probably face lock or fingerprints. When you register on the platform, you can set up your biometrics, scan and save it on the portal. So whenever you want to access your portal one more time, you can use the biometric. Another method is token-based authentication. So this token-based is one of the popular one for you to be able to access any portal. When you try to log in on a platform, you'll receive a JSON Web Token, and this JSON Web Token is what you are going to be using to protect all the API, authorize the user, to manage all the user authorization. So this token authentication is what we are going to be practicing tonight after this slide. Also, you can also use social authentication. This is one of the popular one also. Whether you want to log in or register on any platform, you can see below or above the text box for you to be able to log in or register with Google, Facebook, GitHub, Microsoft, and any other platform that is available and listed on the platform. So, authorization. like I explained, is the process of granting access, verifying what you can do when you already have access to the portal. So the concept is something known as rules and permission. That is, when you're on the portal, your role will determine what you can do. If you are the admin of the platform, you have access to do everything. When you have limited role, probably you are a user or you are a guest, what you can perform on the platform will be limited. For you to have more access on it, admin will have to grant you access or assign more rules, more permissions to your roles. All right. So access control lists define which user can access certain resources, which is what we explain. The permission will determine what you can do. Role is just a name. A user can have multiple role on a platform with different permissions. Ade and Wale can be admin on a portal, but have different permission on what they can do. So the permission will determine what users can perform, operation user can perform on the platform. So we need to understand all these things and understand the difference between them and the use case on when we can use them. So type of access control, the role-based access control, which is what I explained now. Admin have full control, regular user have restricted access. The role will determine what the person can perform on the platform. Then attribute-based access control provide access based on attributes like department, user status, and user identity, whereby all the user will be grouped into the department they belong to, and all the permission will be assigned to the department, not the user. All right. So these are the type of access control we have, and the best practices, security best practices, like I explained the other time on password, we should always ensure to use strong password policy, enforce password length, complexity, and expiration policy. When you're using something like a Google account or Microsoft account, there is a features whereby you can enable to let your password expire. That is, probably you need to be changing your password, rotating your password every month or every three months, and enforce the user not to use existing password. So these are the security things you can implement in the backend system you are designing. Multiple factor authentication is what we explained the other time, and also the token storage. This secure token storage is on the front end side because the token will be saved on the front end, but it's being managed on the back end. All right. So encrypt sensitive data. We've talked about this in our previous class, and I've explained type of the encryption we have. You use the TLS and SSL for your network communication. That is, the SSL certificate on the websites or the server you are working with needs to be managed every time. When you find yourself on the website that is requesting that is notifying you that the website you want to access is not secure, you probably need to check their SSL certificates must have expired. Encrypt stored sensitive information. This is part of the things I explained in the last class, using the password, saving the password, and other personal data. This is very, very important. These are the things you need to have in mind whenever you are designing a backend system. Always understand when and where an operation is meant to be performed. Oh, this data we are handling, this data the user is supplying, this is how we need to handle it. We need to lock this data. We need to restrict access to this data. We need to encrypt this data. These are the qualities that determines good software engineer and a good system. Limit failed login attempts. This is one of the things called we can group as a rate limit. When a user tries to log into on the system, first time the information is not correct. Second time, the information is not correct. Third time, the information is not correct. We can limit it. We can lock that account. Bank use this security measure a lot. I believe we must have someone that have experienced this type of issue with bank. I, as a person, I've been a victim of this before. I try using my password, which probably keyboard is malfunctioning. You input it the first time, the second time, and your bank account will logged. So you need to reach out to the system administrator, give them reason on what happened, provide your information that you are actually the person requesting for the information that they should unlock your accounts. So this is one of the measure you can use to safeguard your system, and it lets user trust the system very well. All right. Conduct penetration testing and regular vulnerability scan. This is more on the cybersecurity part. When you have a system you design, you can contract it out for cybersecurity guys to help you test the system extensively, rigorously. They overload it with requests, set up a lot of layers on how the system can be penetrated. So they will mimic the system. Oh, this is lagging here. Oh, this is a fault here. Your API is lagging over here. Hackers can hack through your system using this. They scan your system. They show you all the data you are meant to be handling very well. You are not handling very well. So that's what penetration testing and vulnerability scan means. So OAuth is basically a system whereby you are not the one handling the authentication and authorization of your service. You hand it over to a third-party server, such as OAuth itself. OAuth is one of the biggest authentication and authorization system. The same thing goes for system whereby you try to log in and you see login with Google, login with GitHub, login with Microsoft. They handle the authentication on their server, but not on your server. So authentication base. This authentication base is um is a general one, like I explained the other time, and this is what we are going to be practicing tonight. Is JSON Web Token. Most API is protected using JSON Web Token, but not all API. And there are multiple ways you can protect your APIs, but JSON Web Token is just one of the mayors. So whereby, let me show us how and how the JSON Web Token is. All right. So when you search JSON Web Token, you can see on the platform, read more about the JSON Web Token. So on what we are discussing right now, the format of what JSON Web Token is all about. See, we said on the structure, it consists of three things: the header, the payload, and the signature. The header consists of the algorithm that the data is being encrypted with. So the header, can we all see? This part is the header. It consists of which algorithm did they use to encrypt it. HS256, and the type is JSON Web Token. Now the payload, that is the data you encrypt into the JSON Web Token, you store in the JSON Web Token, is the part starts from this part to this part, and the data that is being stored in it consists of sub, the name, and the time it is being issued. This IAT is the default data that is combined into the data, but this two is what the person store. All right. So the signature is the last part. That is also the process of how it is being used. Is being encrypted. All right. So the use case, user session, and single sign-on. When you use it to manage the user session. When the user tries to log in on the system, you keep track of the user login, the session, save it in the token, and return it back to the front end to be able to authenticate the user and authorize the user. A single sign-in is still the same thing. When you try to log in, So implementing the authenticate authorization in code, when we talked the other time that you can keep track of user role on the system. That is just the explanation. But how do we actually manage the user role? If user login, you need to check if the user is an admin to grant them access to what they need to have access to. So this is how you can do that. You can define a middleware that extracts the role from the request. Check if the role match what the role is supposed to be. Let's assume the user role, the request.user, the role assigned to that user is admin, and the role we define is like let's assume we define it as auditor. So the role does not match. So you need to return 403, the access is denied. So this is a middleware check on the request. So we are going to implement this now. All right. So best practices for API security. Ensure all endpoints are served over HTTPS, right? Your TSL and SSL certificates must be renewed whenever it is expired. Always ensure that your server is served on HTTPS. We have HTTP and we have HTTPS. The S means secured. That's where you set your TSL and SSL certificates. Rate limiting. Always limit the number of requests to prevent abuse. Yeah, because the server load, so the server can you determine the size of your server and limit all the API requests to reduce the amount of load your server can handle. So API key and token management. Ensure the API keys, whether you are managing a data encryption, you're using an API key, you are requesting for the API key or token, they must be secured. If you are sending an encrypted data to the front end, and the front end also need keys to encrypt it, the front end, the key exchange process need to be encrypted front to back. The key must not be used in the code, plain text. Keys and tokens can be saved in a vault, whereby another API request will be make to retrieve the keys or the token from the vault. That is, the vault will only limit a specific whitelist IP address to retrieve all the keys. So these are the specific measures. If you are, let us assume you are building a financial system and you did not encrypt all the necessary information you encrypt. When an hacker hack your system, they have access to all the data, all the keys, all the tokens that you're using to process the payments, settle the customers. So they have access to all these keys. They can literally just copy the keys from your code base or from your server that is being displayed on your web browser, put it in the code they have on their hand, and start processing it on their own. Whitelist their bank account, direct funds from your customer bank to their own bank, to their own accounts. So these are the security measures. These are the things that can happen if all these things are not being taken care of. And also the SQL injection I explained the last class. That is, SQL injection can be used to have access to your database. They inject query into the query params, write their own query, retrieve your data, or manipulate data in your database. So now I'm going to go back to the code and try to implement all these things. Now, as we understand that what we have in our database now, we have name, position, age, and salary of the user. Now we need to implement to add a column to save the username and the password of the user. So now I can just implement, let me add a column to save the password and the username. Um, okay, no, all right. Um, let us write a query for that. I don't want us to. I don't want us to use it. So we can write a query to do that. Alter table employees. Do we still remember the query? Add column. What column do we want to add? We want to add email, or let me just use username. Username, the size varchar 255 not null. That is, the column must not be null. Then the same thing goes for the password we want to add. After, okay, okay, let me add it after name. So if I run this query, now can we all see that we've been able to add, oh, we've been able to add the name and the password and the username to the database. So now we can now implement this into the system. So we can now accept username and password from the user. We can also update our query to consider username and password. So I want us to pay attention to what will happen here. So after the salary, we must not save a plain password. But before we do this, before we encrypt the password, I want us to see that this will save the password. All right. So I'm going to empty the database now. I'm going to empty the table now. So now the table is empty. The server is running. So I need to restart the server. So when I restart the server, I can now add that information over here. Username. What username? My username. Let me use Mortado as the username. Mortado. Let me use dev Mortado as the username, and the password at password 1. So now if I hit the request to send data to database, it must save the data into database. Now the data has been saved. If I refresh my database, the data is in database now. Can we all see? But there is an issue here. The password is being saved as a plain text, which is wrong. Now, how are we going to do this? We need to encrypt the database and the password. To encrypt the password, we need to make use of Bcrypt.js to encrypt the password. So there is a library for that to encrypt a plain text to encrypted information. So now this bcrypt already handled the algorithm to encrypt all the text we sent, to translate it to encrypted text. Now, how do you install it? Npm install. We are going to run npm install bcrypt.js. We require it and follow the process of encrypting it. Can we all see? All right. So I'm going to run this query now. Npm install bcrypt.js. So in our terminal, all I need to do is stop the process, type npm install bcrypt.js. Yes. All right. So it has been installed. We now need to follow the next step, that is to require the bcrypt over here. So when we require this, we also need to const bcrypt equals require bcrypt.js. So when this is done, what else do we need to do? We need to follow the next step, that is to encrypt the password. So now when we receive this password from the URL, we need to encrypt it. Const encrypt password equals to a weight of bcrypt dot hash. We need to hash it. What do we want to encrypt? We want to encrypt the password, comma. How many times do we want the algorithm to run? The number of sorts, the sort length to generate. The default is 10. So now this will generate encrypted password for us. So now we now need to save the encrypted password instead of saving the password directly. So we replace the password with encrypted password. So now if I restart the server, okay, I need to truncate that data. Let me empty that data table one more time. If I empty the table, I've been able to empty the table. So run it again. So I try to run this again. Data has been saved. So if I refresh the table, we now have encrypted password instead of plain password. Can we all see that? All right. So we now need to implement a login whereby we need to be able to log in with the username and the password we register with. So now we need to be able to generate a token when a user login, because the token is what we are going to use to authorize and protect the rest of the API. Like now, we are going to write an API to get user salary, get my salary. That is, I should be the only one to have access to get the salary. And for me to be able to get the salary, I need to log in. So now, what is going to happen? user, we've been able to register the employee. Now we now need to write the API to login. Employee login. So for you to be able to log in, all you need to pass is your username and password. So the API is going to be a post request, and the URL is going to be like this again. So employee slash login. I want us to pay attention to all these things I want to explain here. App.post, because a lot of check is going to come in place now. All right. So now we need to extract username and password from the request, because that's the only thing we're expecting. Now we need to en- we need to encrypt the password and check. We need to check if the information the user pass actually match what we have saved in our database. Do you understand that? So what we are going to do now, we are going to retrieve the username, the email and the username from database. That is, do you actually register with the username? If so, okay, let us compare if the password you input match it together. Check if email exists. So what are we going to do? We are going to write a query. So we get this. Um, we query to do this. All right. So to do this, so we need to make a deep database connection. Select all from employee where username equals, where the username actually match the username we receive from the request. So we pass the username here. Now we now need to check if it match, if the email, the username with that record exists. So let us check this. So if we try to implement a login, employee login, post https this slash login, then we have this like this. So we now run it. Okay, I need to restart the server. So if I run this, uh employees slash login post. Oh yes, I've not had login to the request. So I need to start the server and rerun it. So I want us to pay attention to what I want to do here, because the logic, you need to be able to check it. So unknown column. Okay. Where is the query? Select all from, okay. This needs to be as a string. All right. So we test it again. Now, can we all see what this data is returning? This data is coming as an array, not as an object. So now our check need to be like this. It's a simple thing. It's coming as an array. We only need to check the length of that array. So we're expecting if the result dot length equals 0. That means that if we input wrong username, that is no username match that record, the data we are receiving is 0 from database. So we need to throw an error that the information does not match. So I'm coming. Do we actually? Okay. So we can return so rest dot the data. We are just sending a message. User not found. Okay, let me use a generic one. Invalid login, because you are actually imputing the data invalid login. So if I try to put a wrong username, can we all see wrong username and send it invalid login? Because there is no user with this username with xxx, no user with that username. We are getting invalid login. But if I pass the actual login, actual username, it will this data will match. Now, when the data match with the username, we now need to compare the username that is being saved and the username that user sent. Now, this is where I need us to pay attention. We remember that the user is sending a plain username, a plain password. We are sending a plain password, but the password that is being saved is an encrypted password. Now, that's why the Bcrypt.js we are using, because we will not be the one to write the algorithm for the comparison ourselves. The library will handle that for us. So now we need to do the user const, let me name it employee equals results, the first index of that data. So now we now need to compare the password. Const compare password await of bcrypt dot compare. So it's going to accept the plain password the user sent to us, the password. That is the password we retrieve from here. Then the encrypted password, can we all see the hash one? The hash one is coming from the database, from this employee, is coming from this data. So now, if this comparison does not match, we need to notify the user that the information you input is not valid, invalid password. So let me show something. Invalid password. I want us to pay attention to one thing I want to do here. If not compare password, we should actually return this. Now, let us run this system. I restart the server. Okay, there's a bug here. Return. So I need to restart the server. So when I start the server, the username is correct, right? But the password check. Let me input a wrong password. This is a wrong password, right? So if I send this information, invalid password. Can we see that? Invalid password. But as a developer, we must not make a mistake that when an attacker is trying to access your system, they input wrong username. You send them a defined message that invalid username. They will keep using multiple username until they find the perfect username. The stage pass, okay, username is correct. You now tell them invalid password. They will know that, oh, the password is the wrong information. They've already get the username right. The password is the next thing they need to do. So if you are designing a system, authentication system, your message needs to be defined across all the check, not to allow hackers understand what the system is all about. So now, when the username is match the record in our database, the password also match the record in our database. That means that the login is successful. So now, if we return a message that login is successful now, login successful. So this is what we are going to do. Let me restart the server. So we are going to go on a 10 minutes break after this test. When we now come back, we are going to implement on authentication using the token. So this is the correct username and the correct password. So if we try to send it one more time, login is successful. If I input wrong username, I need to get invalid login. If I input correct username but invalid password, I need to get invalid login again. But if the username is correct and the password is correct, my login needs to be successful. Can we all see that? So we are going on a break now. When we are back, we are going to continue where we stopped. I did login. Where I passed the actual login. Hello. Hello, are we back? Can you guys hear me? Before we continue the class, can you guys hear me? Hello, can you guys hear me? All right, you guys can hear me. So now we've been able to write a successful login API, and we now need to generate a token to allow the user to access protected API using that token. Now, we need to generate a token, and we need to follow the pattern we explained the other time, JWT pattern. So now, to use that, we also need to install the JWT JSON Web Token. It's called JSON Web Token. To generate a token. So now this is the process to install it. npm install JSON Web Token. We install it again. So what we need to do is check our package.json. This is the list of library we've installed. We've installed Bcrypt.js, Express, MySQL, MySQL2. Now we need to install the JSON Web Token. So we need to stop the server that is running. Type npm install JSON Web Token. npm install JSON Web Token. So now this will be installed. So now we need to remember that there is a pattern we need to follow. We need to understand, we need to pass the data we want to encrypt. So now we now need to follow the pattern on how the token will be generated. So we take a look at the documentation. How do we actually do that? We follow the same pattern we used the other time. We require the JSON Web Token, then create JSON Web Token.sign, pass the data we want to encrypt to it by that. So if you also want to verify it, how do we verify it? JSON Web Token dot verify. This is how to verify it. You pass your token to it and the key you use to encrypt it. All right, so let's jump right into it and implement it now. So let's get back to our code. We've installed JSON Web Token. We need to require it at the top. Yes, we need to require it the same way we require Bcrypt. This is installed. All these libraries. So we've been able to use just 4 libraries to run our system. So we need to generate the token over here. Generate token. So for us to generate it, const token equals JWT dot sign. So what data do we want to pass here? We want to pass the employee name. We want to pass the employee name and the employee username and the employee ID. Let us pass that. The ID, employee dot ID, employee name, employee dot name. So let's pass this to data because those are the data that is very minimal for us to use. We must not expose all our data out. So we need to use a key. So let me use a simple key. Let us write it up. Let us write it here. Const secret key token secret key. So we are going to use a auto-generated alphanumeric. So this key is what we are going to be using to encrypt and decrypt the token. So now, for testing purpose, I want to test it before I extract this token out of this code because it was not be outcoded in our code. So that's what I'm going to do right now. So we pass the key, token secret key. Now we need to define how long we want the token to stay before it expires. So expires in 1 hour. So let me define 1 hour. If you tell the token to expire in 5 minutes, it will actually expire in 5 minutes. So let us use 1 hour. So I will come back to do that. So now if we get this token, we need to return it to the user. So now I want us to see this message, login successful, and the token. So if I restart this server now, I start it one more time, test the API again, login. So this is what we get from the API. We get the message, login successful, and the token. Now, I want us to pay attention to this. When I explained to us the other time the structure of JSON Web Token, we understand that JSON Web Token consists of 3 data. It consists of header, the payload, and the signature. And this is what we have here. Can we all see that this is what made up our JSON Web Token that we generated just now? The header, the data, that is the payload, and the signature. So now, if I copy this data and paste it to JSON Web Token, JW, I want to show us what is inside that data. So you paste the data here. You'll see that the token we generated, this is what we put inside the token. That is why we must not put sensitive information in. We only need the role of the user, the ID of the user, the name of the user, the path of the user. That's all. Those are the things that need to be put into token. Don't put sensitive information inside your token. Now, this information is what is inside our token. Now, we're now going to use this token to authorize our protected API. So now we need to understand the concept. We want to protect some API. For example, API that allow user, API that lists all the employee. All this data need to be all this data need to be protected. Data to a delete employee. This data needs to be protected. You need to log in before you can do all this action. The only action that you can perform that is not protected is log in and register. All these actions need to be protected. So now, how are we going to protect all these API? This is where the concept I explained last time comes in. Something we called a middleware. We are going to write a middleware that intercepts between the request and the response. If you remember the concept I explained last time about the middleware, it only operates on response and middleware, and response and request and response. When the request hits the server, you want to perform some check before you return the response. The same thing we did here. The logger. Where's the logger? This middleware logger. When the request comes in, do this. This is a middleware. Now, I'm now going to show us, we are going to mimic the same thing to protect our API. So which API do we want to protect? Let us move it here. We want to protect API that allow user to fetch all the user, to get all employees, to delete employee, the two API. Now, we can see that we are not, whether you log in or not, this data, you can access it. So now how are we going to protect it? So we are now going to write a simple middleware check that will always check whether a token exists in the header or not. Now, how are we going to do that? So let us do that now. Const authentication check. So authentication check, like we explained, since it's a middleware, is going to intercept the request. Do you still understand? It's going to intercept the request. I want us to remember this. To accept the request object, the response, and the next, because it's a middleware. If all the check is successful, if all the check fail, any of the two, the next will pass the execution to the next step. So now, this is what we are going to do. Let me show us one thing now. Console.log authentication check in process. Can we see what I'm typing? Authentication check in process. This authentication check in process needs to happen when we want to get all employee, because you need to be logged in before you can get the employee. When you want to delete the data, you need to be protected. So now, inside our route, this is where we are going to put it. We want to protect this API, protected API. Now we are going to put this over here. Auth check. Can we see? After you list your routes, authentication check, because it's a middleware. Can we see? It's a middleware. The same thing will happen here. When you want to get all your employee, because it's a protected API, auth check. I want us to see something new. Now, if I stop the server and run the server one more time, I try to get this API. It will not work. Why? Because the execution is still inside that block. I did not instruct it to pass the execution to the next line. All right. So if I run this code, I want us to see my log console. This will only be running without returning response. Can we see that? Authentication check in process. The API with timeouts because I'm not returning anything. So now for this authentication check to pass the execution to the next process is a middleware. You need to execute this next. I explained this the last time when I'm explaining this middleware implementation. So I'm still doing the same thing. So if I stop the server, I run it again. This is going to work, but I'm not checking anything. Auth check in process. Now, what are we going to do? Can we see the API is still here? We are not protecting the API yet. Now, we now want to implement the process of protecting the API. How are we going to do that? What is we are going to do is that the token we are sending to the API, we are receiving the token from login. That token, we need to pass the token to the API request of get employee and to delete employee. We are now going to extract that token from the API. I'm not speaking in tongue. Let me explain it to us. We have something called header in our API. Every API has something called a request header, and they all have their functions. Content type. This is the header of this request. That is, you are passing all the data you send to this request as a JSON object. You can instruct it to accept text, anything you want. Read up on content type on the API. Now, we now want to pass token to this, not login, to get employee and delete employee. So what are we going to do? Here, you need to pass it. Let me name it auth token. Auth token. So this token is what we need when we log in. Let me try and log in and copy the token. So this token is what we need to authorize our request. Okay, so I've copied the token. I'll paste it here. Okay, copy the token and paste it into the header. All right, so now we now need to extract this token from this specific request. How are we going to do that? We are going to extract it like this: const token. Do we still remember the process of extracting data from the request parameter from the request body? But now we've implemented the process of extracting data from the request parameter. I explained that in the last class. We've implemented a process of extracting data from the request body. That's the second process. The third process, extracting data from the request header. That is what we are going to do now, which is the new thing. Request dot headers. So let me show us all the things that is consist inside console.log request.header, all the informations a single request holds in the header. So if I start this and run it again, can we all see the log inside the specific request that we send now? See what we receive over there. We receive the user agent, which is the default one, content type, the token I'm sending. Can we all see that? The accept encoding, all the things is supported, the host, the connection type. So when you're running this on a specific web server, the header might be much than this. So, but just understand the concept and understand what you are doing. So we need to extract this auth token from the header. So, all right. So the header auth token. So if we log this token, you run it again. We want to see the token in the log. Can we see? This is the token in the log. Now we need to implement a check. What if we did not pass the token to the header? That means you cannot access the request because it is protected for a reason. You must always pass a token to that request. So if not token, so we need to return a message. Invalid. Okay, let us use a simple word. Token required. All right. So what now? You pass a token. Okay, let's test this. We said the request must be a protected request. That is, you must always pass a token. Now we need to test it. If I comment this, I run it. The error message, you must always pass a token. The same thing goes for delete operation. If you run this delete, it's the same thing. Token, pass a token. Now, what if you now pass a token? We remember that we set the expiry to 1 hour. Let's assume the token. Let me run this. Let me set up the expiry. Let's set it to 2 seconds. Let me check. Expiry. All right. We can set it by days, seconds, 1 minute, 60 minutes, 60 seconds makes 1 minute. So, all right. You can use the milliseconds. All right. So let's try that. I want us to set it to 1 minute. Let me check this to 1 minute. So if I stop this and run it again, so the token must expire after 1 minute. So if I run this again, if I copy the token, check it over here. Let's see when this will expire. It will expire 8:35. What's the time? 8:35 to 47 seconds. So let me try. When it is 8:36, we are going to try the token. So the token must have expired by then. All right. So now let us write the logic to verify that token, because if you pass the token, we must be able to detect if the token you pass has expired. So now let's write that check. So we need to use the JWT const verify token. All right, so okay, JWT dot verify to verify the token we are getting. So the token we are getting, the key we use to extract it, token secret key. We use to encrypt it, the token secret key. So if this data is wrong, okay, console.log verify token. Now we need to check if not verify token. That means that the token has expired. So the message, we are going to use the same message, but for the process of testing now, token expire, we need to understand the message. But after we understand the message, we are going to save it back. All right. So let me run it again. So we expect that that token must have expired by this time. So if I run it again like this, um, what's the time? Expiry. The token must have expired now. Let me check it again. Mm, expires. Oh, I'm checking the wrong one. Ah, the time, the expiry is not set. Ooh, okay, our seconds count. So okay, all right. So if I want to set it to expire in 2 minutes, this is what I'm going to do. Where am I generating it? So 60 seconds become minutes. So I want this to expire in the next 1 minute. So if I try and stop the server one more time and run it again and try to log in, the token that we generated, so we generated a new token. Let's check the expiry time. When did we generate this? We generated this by 8:39. So by 8:40, this token must expire. So when is the expiry time? Exactly 8:40. So we are right now. So let us run this again. So let's continue our check, our implementation. So if I try to get the employee, all right. If I try to get employee now, this will get employee data because the token is still valid. The token has not expired. Can we see that we are getting employee data? So now our check is working. Our check is working. Over here, we need to save authentication data, auth data to request. I will explain this to us, but I want us to verify our token. Now, we've been able to protect, not only protect our API, to also write all the logic to protect it. The second logic that we need to write now is to actually verify if the user actually exists. If the user exists. Now we are going to write that logic when we test our data. So now this is 11:41. The token is expected to expire by when? Okay, 8:40. So now let me try and run the server. I did not stop it. I'm just running it again. So I expect the token to tell me the token has expired. Okay, still not expired. I'm curious why this is still not all right. Verify token. This is working, even though the token was have expired. All right, hold on. What's the time? Okay, I'm coming. Let us continue on this. Are we? We're going to come back to solve that. So now the next logic we need to write is to verify if the user actually exists in the database. We've been able to get the authenticated user, right? We now need to verify the user. So what we need to do is just write the check to verify, to extract that user data from the database. So now we've already write the check before, so we just need to pass it again. So now verify the user, the same logic, all right, but we're only checking based on the information we put in the token, the ID and the name. So now select employee where ID equals to the verify token dot ID and name equals data we save inside the token. So inside the token, verify token dot name. So if this data, if there's no user with that information that is stored inside the token, we need to show this user not found, right? So if I restart the server and run it again, so on the process of this, the user actually exists in the database, right? So the user actually exists in the database. But what if we delete this record, this user record? Now we delete this user record. There is nobody, no user in that database that match the record that is being stored inside the token. All the check must be handled. All the check is the security. Our system must be secured and reliable. So now if I run this check now, user not found, because not only because your token follow our pattern or your token actually consists of the record, the user you use to authenticate your system, your login must actually be valid, must exist in the database. Now all this check must be pass for you to be able to perform all the authorization you need to do. You want all the action you need to perform on the system. Now the user does not find, it does not exist in the database. You will not be able to get all the data in the database with this. The same thing goes for deleting records. You will not be able to delete the record. Now we now need to let the message be generic. the message must not actually define what the issue is to limit the attack or breach on our system. Invalid authentication, because it's in the middleware layer. The same thing for this, the token expiry. The same thing when the user is not found. Now, we've been able to secure our API. So we now need to save that record to request, because we might want to use that record somewhere else. Auth data. The data we get from the from the token. So let me save this. Auth data, the current login user. The current logged in user, the record of the current logged in user. So we save it in the request, because we might want to use the record some other time. So now, if I try to register again one more time, let me stop this the process, run this again. I try to register. Where am I? Where's the API? Okay, you register your user. Data saved successfully. The registration is successful. I try to log in. Login successful. If I try to get employee, oh, this token, this check is not actually valid, because oh, I understand what happened. The ID match. That's why the token works. So the ID match. So if I try to create, let me create another user. 2. Developer 2. 2. 2. I register a new user. So I register a new user. I logged in with this information. So this information, the second user. Now, if I go back to the record database, I deleted the first user. I don't want the users to exist again in the database. So I delete this row. This user does not exist in the database anymore. So that user does not exist in the database. User with ID 2, ID 1 does not exist in the database. But let's not forget the token of the user ID 1 is still what we are using to authenticate. So if I try to get this record now, authentication, invalid authentication, because the record for that specific user does not actually exist in database again. All right. So I can now use the token of the new user, dev2. The token, I pass the token to the API to get the user, because the token, this token record, the user does not exist in the database anymore. So if I pass this to get employee, can we see is here to delete, to get all employee. Now to delete a record, you must be the, if you want to delete your record, let's assume you register on a platform, you want to delete your account, you must be the owner of your account before you can delete your account. So let's implement that check. I want to delete an account. I must be able to delete my account myself. The account ID I want to delete, I pass it here, which is ID 4. The ID does not actually exist. Invalid. invalid authentication. Why do we get invalid authentication? We get invalid authentication because the token we pass over here, the data that is inside this token consists of user with the first ID, which it does not exist in the database anymore. Can we see ID1, which it does not exist in database anymore? We need to update the token to the currently logged in user. This token now, if I check the data of this token, see ID2. So if I copy this token, paste it to delete an account, this will work. Okay. Yes, this is what I'm getting. The token expire. Exactly. Now the token expire. The token is now expired. So that works now. Let's undo it properly. So I want to get employee, but the token already expired. JWT token expire. Where are we doing that? Auth check. All right. So now, can we see invalid authentication? If we do this now, invalid authentication expire, token expire. That's the message we are getting. If I restart this now, we send it again. Get employee. I'm stopping the process before we get there. Okay. Let me check how to properly handle that. Dot verify. You can always come to check the documentation to verify that what you are doing is actually right. You are doing it the right way. All right. Okay. Since invalid expiry is throwing, is a synchronous system operation. So, all right. Let's do it this way. To verify a token, we're going to move all the operation here. Authentication check. Authentication check. Let's wrap all the operation here. So let me show us, because it's a promise. Okay, the token here, comma, data. All right. So now this should work perfectly now. If there is an error, it should throw this invalid authentication. Okay. Else, do the necessary check that we wanted to do. All this check. Then continue the execution. Right. Asynchronous writes. So this data, we're no longer using verify token, we're using data. Yeah. All right. So now let's run it one more time. Get employee. Yeah, we are handling it perfectly now. Can we all see that? Invalid authentication because the token has already expired. let's go through the logic again. We want to verify the token. Over here, when you verify a token, the token, the verify option accept the token, the secret key, and a callback of what will happen. So the callback accepts an error and the data of the decoded token. So now over here, the token can only be two error, whether the token expire or the token is invalid. We can have those to check. The token can only fail. Token verification can only fail when the token is invalid or the token has expired. Now over here, this catch error is catching the to check. When the verification is successful, this will not execute. But when the token verification is failed, this will execute, because the token can only be expired or invalid for this line of code to execute. So that's what is happening here. Now, since our token, this token we pass here, we are using to authenticate this system now to get all employee. The token has already expired. If you copy the token, we copy the token, paste it to JWT token one more time, and check it. Check the expiry. What is the expiry stated there? 850. 850. Can we all see that? But what's the time? 8:57. So if you try and log in again, we are getting new token. We get new token. We use the token to replace what we have here. Replace the token with what we have here. Now we try to get the data. Can we see? We are getting the data. Do we all understand? Now we've been able to protect this API. Can we all understand? Oh, yeah. Can we all understand? This is the code one more time. Hello, do we have any question? Huh. Do we have any question? This is the code. This is the line of code that do all those things. The same thing, the API to get the user salary. So let's write the API to get user salary. API to get user salary. This is it. API to get user salary is a protected API. Employee/salary. So auth check. The user is logged in. We are going to extract the ID of the user, select salary from employee, where the ID of the employee match the currently logged in user ID equals the request.auth.data.id. Can we all see that? Auth.data.id. This auth data means the currently logged in user. The data we save. Where do we save it? Let me show us. Auth data. This data we save auth data to request, because when the user is logged in, we get the data from the token. Is that same data we are going to use to get the user salary. So now if I stop this server, restart it, execute this API over here, get this data, we paste this token here again, get the user salary, employees slash salary, string and error, http employees slash salary. Yes. Oh, I did not update it over here. Employees slash salary. If I restart it, run it one more time, can we see that invalid authentication? We need to log in because the token has expired. So we can even extend the token expiry time. Instead of putting it for 60 seconds, we can put it at 1 hour, 1h. So restart it, log in, process the login again to generate a new token. Login, we generate a new token, copy the token, put it inside the salary token. So you try to get the salary. Can we see that? The employee salary. I'm getting the currently logged in employee salary by just putting the token in the request. Can we can we all see that? So if we check the code again, if you check the code, it's just a simple code. Employee slash salary. You make a database connection, you write query to select the salary by getting the ID of that user from this authentication check inside the middleware. Because this middleware, we've already do all the necessary validation and save the data inside the Auth data. Can we all see that? We've been able to write a a fully functioned, a fully functioning backend system. Now you can build on top this system by extending it, adding more features to it. All right, this will be the end of our class for today. We have just 2 more minutes. Do we have any question? Do you have any question? All right. In the absence of no question, this will be the end of the class, and we are going to meet again tomorrow to round up and finalize our backend Node.js class. Thank you very much and see you tomorrow.